Hi, Moses Oluwasegun. You are welcome back to my YouTube channel. If this is your first time of coming in contact with this YouTube channel, please subscribe to my YouTube channel, watch the videos, like the videos, and at the same time, give me thumbs up on the video. Please, the comment section also is good for you in order to reach out to me. Please make use of it to ask me any question you might feel like asking, and at the same time, tell me how much you appreciate what we do here, and at the same time, please try as much as possible to recommend this channel to everyone around you. Okay, so in the last video I explained the determinants of 2 by 2 matrix. So in this video I'm going to be explaining the determinant of a 3 by 3 matrix. Determinant of a 3 by 3 matrix. Now, before the determinant of a 3 by 3 matrix, you need to understand what is meant by minor of a matrix. So we start with this, minor of a matrix. Minor of a matrix. Now, the minor of a matrix is that determinant, or is the determinant of the leftover matrix when the row and column to which an element belongs are deleted. Now, what that means is this. The minor of a matrix is calculated for each element in any given square matrix. Okay, remember in the last video I said that determinant only exists for square matrices. So once the matrix is not a square matrix, it then means that you can't find the determinant. Okay, so when we are therefore given a matrix, let's say matrix A is the matrix of the elements 0, 1, 4, minus 2, minus 3, 5, 7, 4, and 6 as this. Okay, now minor exists for this type of matrix, and it corresponds to each element in this matrix. So if I'm saying that I need the minor of the element 0, the minor corresponding to the element 0 means I will delete the row that 0 belongs and the column that the 0 belongs as well. So the leftover matrix, okay, I will find the determinant of it. The determinant of this leftover matrix or the submatrix is called the minor of the element 0. So M11 here will mean minor corresponding to the elements on the first row, first column. So first row, first column, deletes them. Okay, so I left with minus 3, 5, 4, 6. So when you find the determinant of this, minus 3 times 6, minus 4 times 5. This is minus 18 minus 20. So this is minus 38. So the minor corresponding to the element 0, okay, is minus 38. Now, in the same way, we can find M12. This is first row, second column. This means delete the elements on the first row, then elements on the second column. So in that case, I'll be having minus 2, 5, 7, and 6 left. Okay, so the determinant of that, minus 2, 5, 7, 6. When you find the determinant of this, minus 2 times 6, okay, then minus 7 times 5. Minus 2 times 6 is minus 12. Minus 7 times 5 is 35. So minus 12 minus 35 will give together minus 47. So the same way, we can have M13. M13 in the same vein will mean deleting the elements on the first row and third column. First row deletes, third column deletes. So we are left with minus 2, minus 3, 7, and 4. So if you find the determinant of this, minus 2 times 4, minus 7 times minus 3. So this is minus 8 minus 21. So this is a plus here. So minus 8 plus 21 simply will mean 21 minus 8. 21 minus 8 simply will give us 13. So we can go on like that as well to find M21, M22, M23, M31, M32, M33. Okay, so if you are given a matrix as this, and then you need to obtain the minor, you calculate the minor for each element of the matrix. Okay, so by deleting the row and column that the element belongs. All right, now once this is clear, then let's look at the determinant of a 3 by 3 matrix. Okay, so I'm going to give you a general definition here. Now, if you are given matrix A, the determinant of matrix A is generally defined as the sum, okay, of minus 1 raised to power 1 plus j. I will tell you what that 1 is. Okay, then A1j, then M1j. J starts from 1 to n. N is the number of columns. Now, when you have to find the determinant of any given 3 by 3 matrix, we have 6 possible ways that can be done. Now, when I say 6 possible ways, I'm not saying 6 different methods. It's the same method. The choice of what to do, how to go about it, is what I'm talking about. Now, if a matrix has 3 rows, like you have in this determinant, this matrix here, 3 rows, 3 columns, you can decide to make use of either the first row element to find the determinant. That's one way. Or you go by the second row, that's second way. You go by third row, that's the third way. Or you don't even want to work with the rows at all. You can decide to work with column 1, that is the fourth way, column 2, the fifth, and then column 3, the sixth way. But you must choose one, either to work by row or to work by column. So now what I've just done here is making use of row 1. This one here is the A1 there is representing row 1. So if I'm taking row 1, that means my J will start from 1 to the number of columns. Now, if I'm going to make use of this as an example, okay, I have 3 rows, 3 columns. So J now will start from, so this one will mean from here now, J will start from 1 to 3. So minus 1 raised to power 1 plus J. Okay, then A1J, M1J. Okay, now the only thing that is changing here is this J. J is going to count from 1, 2, 3. That is talking about the number of columns. Column 1, column 2, column 3. So this summation here is just talking about the fact that we are adding each time for each value. Okay, so in this case here, what this one will mean now is this. We are going to have this to be, when J is 1, when J is 1 here, this is going to be minus 1 raised to power 1 plus 1. J is 1. This is A11, then M11. When J is 1, replace J with 1 there. Then plus, this plus now is representing the summation here. When J is 2, J is 2 means we are going to have minus 1 raised to power 1 plus 2, A12, M12. Then plus, the last part of it is when J is equal to 3. When J is 3 in this case, we have minus 1 raised to power 1 plus 3, A13, M13. As simple as that. So what then are we saying here? Let's come back to this place here. A11 is the first element on the first row, first column. That is 0. Then A12 is the element on the first row, second column. That is 1. Then A13 is the element on the first row, third column, which is 4. So I'm taking the first row element to calculate the determinants here. And of course, M11 here means the minor of the elements corresponding to the first row, first column. Okay, so find the minor of this. This one here has been calculated here as well. That's minus 38. Minus 3, 5, 4, 6. You have that here. Then M12 here is talking about the minor corresponding to the element on the first row, second column. Minus 2, 5, 7, 6. That is what you have here. Okay, 7 here. So, and this has been calculated, minus 12, minus 35. Okay, that's minus 47. And as well, M13 is talking about the determinant of the leftover matrix, the minor corresponding to the element on the first row, third column, that's corresponding to 4. Okay, so that is what is calculated here. Minus 2 minus 3, 7, 4. Minus 2 times 4, minus 8. 7 times minus 3, minus 21. So minus 8 plus 21 is 13. So all we need now is minus 1. 1 plus 1 is 2. Minus 1 raised to power 2 is positive. So that's plus 1. So we simply add this as A11, M11. Okay. Now minus 1 raised to power 1 plus 2. 1 plus 2 is 3. So minus 1 raised to power 3 is minus. So this sign will be minus here. A12, M12. Okay. Then plus the next one. 1 plus 3 is 4. Minus 1 raised to power 4 is positive. So this is A13, M13. So let's just replace all of this here. A11 is 0 multiplied by M11 minus 38, then minus A12 is 1. 1 multiplied by M12. M12 calculated is minus 47. Minus 47 plus A13 is 4. Okay, first row, third column, that's 4. So 4 times M13 here is 13. So every other thing here you simplify. This is 0. Okay, 0 minus 1 times minus 47 is plus 47. Then plus 4 times 13 is 52. So we have this together. 7 plus 2 is 9. 4 plus 5 is 9. So the determinant of this matrix A is simply equal to 99. All right. So when we want to find the determinant of any given matrix, okay, just follow this. But does it mean you have to write out all of this each time? No. You don't need to write out all of this each time. Now let's look at another way to do this without having to write out all of that. Okay, so we look at what is called the sign convention. The sign convention will make it easier for you to be able to get these determinants done in no time. All right, now what doing by determinant is the sign convention. The sign convention here. The sign convention simply tells us the sign that precedes each element in each row or column you want to use. Okay, and we are simply making use of this. Minus 1 raised to power 1 plus j. Okay, so in this case, we are using the general case here. This is what we are saying here. Minus 1 raised to power I plus j. So first row, first column, that is 1 and 1. 1 plus 1 is 2. Minus 1 raised to power 2 is positive. First row, second column, 1 plus 2, that's 3. Minus 1 raised to power 3 is minus. Then the third column, okay, 1 plus 3, that's first row, third column. 1 plus 3, that's 4. Okay, so minus 1 raised to power 4 is plus 1. So now all you just need to do, if you do the same thing for others, what you are going to have here is just alternate sign. Where you have plus, this minus, plus. So this one will be plus, minus, plus. Minus, plus, minus. Plus, minus, plus. This is what we mean by the sign convention there. Now, I've used row 1 to calculate the determinant. Let's use another row. Or let me take column 1. Okay. So using column 1, using column 1 now of the matrix. Okay, if I'm going to use column 1 of the matrix, don't forget each element multiplied by its minor. Each element multiplied by its minor. Each element multiplied by its minor. So for the column 1, I have 0, minus 2, and 7. So in this case here, the sign conventions corresponding to 0 is plus. For minus 2 is minus. For 7 is plus 7, is plus here. So all I'm saying now is that the determinant of matrix A in this case will be 0 is positive here. So you can just say plus 0 multiplied by, okay, 0 belongs to row 1, column 1. Delete the two of them. We have minus 3, 5, 4, 6 left. Minus 3, 5, minus 3, 5, 4, 6. Okay, now I've taken the first element here, I'm taking column 1. So the next element is -2. The sign corresponding to -2 is minus here. And so we say minus the -2 itself multiplied by its minor. Okay, the minor of -2 means delete the row that -2 belongs and the column it belongs. So we are left with 1, 4, 4, 6. 1, 4, 4, 6. So that's the second element. Now the third element is 7. The corresponding sign is plus. So we say plus 7 multiplied by its own minor as well. The minor corresponding to 7, delete the row 7 belongs and the column 7 belongs. So we are left with 1, 4, -3, 5. 1, 4, -3, and 5. So every other thing now is just to simplify this. So plus 0 is the same thing as 0, okay, bracket. When you find the determinant of this, -3 times 6 is -18, -4 times 5 is 20, okay. Minus times minus here is plus. So this is 2 bracket. 1 times 6 is 6. -4 times 4 is 16. Plus 7 bracket. 1 times 5 is 5. -3 times 4 is -12. Okay, so if we simplify this lastly here, okay, let's simplify this lastly here. Of course, 0 multiplied by anything in bracket is still going to be 0. So we have this to be 0, okay, then plus 2 brackets, plus 2 brackets. 6 minus 16 is -10, okay, then plus 7 brackets. 5 minus -12, that is 17, okay, this is 17 here. And so if we simplify this now, 0 plus 2 times -10 is -20, then plus 7 times 7 times 17, 7 times 7 is 9, that's 49, okay, then 7 times 1 is 7 plus 4, that's 11. So we have -20 plus 119. So that simply means 119 minus 20. So this is 9. 11 minus 2 is 9. So here we have 99. Okay, so if you look at this, 99 there, we have the same result as 99 here. So when you want to find the determinant of any given 3 by 3 matrix, you can decide to go by either rows or columns. You can use any of the rows, you can use any of the column. So I need you now to practice with using the second row, okay, and the second column, okay. And if you wish, you can make use of the third row, the third column. So you do the practice and let me see your comments in the comment section if you are able to solve this. So when you want to calculate the determinant of a 3 by 3 matrix, it's a simple thing to do. But like I usually say, if you don't pay attention to what you do, 2 plus 2 may appear to be 22. So your focus is very, very important, okay? So it's important that you concentrate and focus on it. Any misplaced sign in this determinant here will mean a wrong answer. So please take note of that. Now, one important thing again before I leave today is that if you have any row or column of any given matrix, any row or column of any given square matrix, okay, the determinant, if any of those rows or column is 0, if any row or column of any given square matrix is 0, automatically the determinant of such a matrix is 0. What do I mean by that? If you have matrix P to be 0, 0, 0, 1, 4, 7, 8, 9, 10, the determinant of this matrix is going to be 0 because I have a complete row that is what? 0 here. If matrix Q has the same thing, 0, 0, 0, okay, let's say 4, 8, 9, 7, 7, 7, As long as a full column here also is 0, the determinant of that matrix is going to be 0. Okay, so it's important. Then another thing is that when you have the rows of the matrix, okay, exchange, it does not affect the determinant as long as the elements are not changing. If a row is exchanged with another row, or a column is exchanged with another column, okay, the determinant still remains the same. Okay, so that is the thing there. So in this case here, I will leave this at this point. Okay, so in another video, we shall be looking at solving some likely problems, okay, equations related to this determinant, right? So but this is how determinant of a 3 by 3 matrix is calculated. All right, so please, if this is your first time coming in contact with this channel, please subscribe, recommend, and share with your friends, okay, so as for us to be able to reach a larger audience. And at the same time, you are helping them, because I believe that this discussion on this YouTube channel are very, very much comprehensive and easy to follow. So there's no bogus grammar here of one sort of a vocabulary or the other. So it's in a plain, simple English that anyone can easily understand. All right, so in the next video, we shall be looking at problems related to this determinant, okay? And that will be the end of the discussion on determinant before every other aspect is discussed. All right, so let's see in the next video.